Okay, it seems the number of attendees has stabilized, so I think we can start the webinar. Welcome everyone to this first webinar that we will have for the launch of the what we call the Vegetated Land Cover Characteristics. It's a production that has been ongoing for a couple of years now, and we are very excited to finally show and invite you all for what is about to come in the products of forest, grassland, and also the novel crop types. More on this later. So I'm here just going to introduce us and the webinar in itself. Please mind that this webinar is being recorded. Also, of course, follow general webinar courtesy rules in chats and etc. And also, please make sure your mic is on mute, at least until the Q&A session later when you're presenting questions. And then we will have a Q&A, as I mentioned, later in the webinar, but we also have this Slido running throughout the webinar. So please make sure to already now scan with your phone or enter the Slido webpage with the provided ID there. And we will have a poll going, running through the webinar, asking some questions we're interested in to know of the participants, but also you can post your own questions in the Q&A section of the Slido. So post whenever you come up with something during the webinar, and we will handle them then in the Q&A session later. Next slide, please. And as I said, this is the first webinar in a series of webinars we have for the launch of VLCC this autumn. Here we will go through kind of introducing the whole product family, including all these three products for forest and grassland and crop types. We will go through the methodologies that and the models that have been applied to produce these products, and also the data access, upcoming data access. And then in the upcoming webinars 2, 3, and 4, we will dive more deep into the thematic applications of these products, also inviting guest speakers to present how they are using these type of data or planning to use these type of data, or planning to use the VLCC products by themselves. So please use the same registration link as for this webinar. You can also, if you haven't already, you can also sign up for those upcoming webinars, so you will get notified when they're approaching. And as you see, they're essentially one half or maybe every 2 weeks, every third week. So this next one is on 30th of October. The one on grassland is on 19th November. And then we have the final one on crop types on the 10th of December. Next one, please. And I will here run through the agenda of today's session, also presenting the speakers. So I can start with myself having this general introduction. I'm the product owner here at the Copernicus Land Monitoring Service. My name is Ludvig Forslund, and I'm the product owner for the Vegetated Land Cover Characteristics, this product, and also our other vegetation product called the High Resolution Vegetation Phenology and Productivity. Then moving onwards in the agenda, we will have a bit of a lead up to where we come from in terms of these products in the VLCC. The VLCC is a new product family categorization, let's say, but many of the products have been long runners in the CLMS for quite a while, previously called the high resolution layers, and it runs all the way back to the beginning of the service. This session will be presented by André Stumpf from GAF, who you can see here in the list of panelists. And further, we will move on to have a look into the methodologies for the full VLCC model. These will be presented by Christian Siegert, also from GAF. And I should also say GAF is part and leader of the consortia for VLCC, and they are together with colleagues from Vito and GeoVil. Vito is handling mainly the crop types and cropping patterns, while GeoVil is handling the grassland and mowing events and also the user uptake. Moving on in the agenda, how to access data will be presented by Tanja Gasper from GeoVil. The internal verification and validation, we will go back to Christian Siegert, and then for summary conclusions, Q&A, we will again go back to me. I forgot to mention, by the way, Casper will also present in the methodologies and use cases. All right, I think then we're ready to leave the word, hand over the word to André. But before we do that, there's a Slido question already in the poll presented. So please visit the Slido and answer that question, and I will hand over to André.
Thanks, Ludwig. So there are quite a few methods and mapping products that we will see today, and of course they did not emerge from nothing. So there was quite a bit of research and development and previous projects to get where we are today. And a good starting point is probably the GeoLand research project, so FP6, FP7 in 2004 and 2008, which were rather large research projects on initial research and development for a pan-European land cover mapping, to develop methods and lay the fundamental stones for that. And in 2012, then the torch was picked up by EEA to start what was called GMES initial operations. So Copernicus was still called GMES at that time. And this was really the start of the Pan-European Land Monitoring Service and the production of the first high-resolution layers for the reference year 2012. Of course, there was no Sentinel-1 or 2 at that time. So this was still done with Resourcesat-2, an Indian remote sensing satellite complemented by Rabbit-Eye and Landsat, to map the first 4 layers: forest, imperviousness, and wetland and water bodies at the time at 20-meter resolution. Another update, so then entering a 3-year update cycle, was done for 2015, still at 20-meter, mainly still on Resourcesat, Spot 4 and 5. And then only in late 2015, the very first Sentinel images became available. The portfolio was then slightly rearranged, so there was still forest and imperviousness. Grassland was added. Water and wetness was kind of joined together to one layer with slightly different specs, and a new layer was added to the family called small woody features, which was more on VHR data, mapping on VHR data. And then another research project was carried out between 2017 and 2019, H2020 budget line with 5 partners to prepare even more for the upcoming, let's say, full availability of Sentinel-2 data, develop new products and new efficient methods. And one of these new developments was, for example, the mapping of a first crop type classification, which we will see today had its fruits as well. Another update then in 2018, this time first time fully on Sentinel-2 data and first a big step from 20-meter to 10-meter resolutions. A lot of data crunching and also therefore the moved to cloud-based processing for the first time in these productions. so more on at least more on a public cloud. Then now we are here today. We started with VLCC project, or this envelope for mapping the vegetated land cover characteristics. So out of these HRLs, we are following up on forest and grassland, and as you will see, there's a new crop type and layers on agricultural practices in the portfolio now. So we started in June 2022. We have produced 5 years so far. And for further details, I hand over to my colleague Christian Siegert, which is currently project manager at GAF for the VLCC production.
Thank you, Andre. I will start with the key benefits and the general technical specifications of the new HRL-VLCC product suite. First of all the three major product groups, forest, grassland, and crop, are harmonized in this new product group, and the crop product group are now also a completely new feature within the HRL product suite. The HRL forest and grassland products are continued, and also with a densified timeline now also continued, and the information gained from these layers is now not on a three-yearly basis, but an annual update cycle. All of these main status layers come with a spatial resolution of 10 meters, and the change layers for the grassland and the forest products come at 20 meters spatial resolution. As mentioned before, all these main status layers are now produced with yearly updates. The grassland and the crop products were started the production started for the reference year 2017, and for the forest products, the production start was 2018. All of these products are provided with pan-European coverage, and in this context, and at that stage, this means the products cover the EA38 area, and an upcoming product phase, there will then also be the areas of the United Kingdom be produced, so that the former EA39 area will be available once the product will be concluded. Here, there is an example shown for the key benefit of the annually updates of the products. Now, on the left side, we see a Sentinel-2 scene in Western Germany, mainly showing forested area, a mix of coniferous and broadleaf trees. And on the right side, there is the same area shown in 2021. And where it's already visible that there were quite a lot of clear cuts and also some dead trees that are still standing there in 2021. And those the Sentinel-2 scenes already show the massive decrease of coniferous tree cover. And in the center, you can see now the timeline from the tree cover density product on the left side, and the dominant leaf type product on the right side, showing the tree cover for broadleaf trees with these brighter green in this brighter greenish tone, and the coniferous trees in this darker green tones. And here it's clearly visible that especially the coniferous tree cover decreased in this 3 years. So in 2018, there was basically equal distribution of broadleaf and coniferous trees, but then the coniferous cover was or is still decreasing due to the drought effects that started in 2018, and then the increase of bark beetle activity, which lead to the death of most of these spruce stands that are present in these areas. Then yeah, here this is also shown in this upper marked area. There is the tree cover density, also highlighting that in 2018 the tree cover was still quite high. Note that trees were visible back then. In 2019 there's already a slight decrease in tree cover density shown with this lighter greenish tones, and then in 2020 and 2021 with the clear cuts of these sites, then there's no tree cover visible and mapped anymore in these areas. Then the second major improvement or update in these HRL-VLCC product suite is now the provision of information related to crop areas. The crop type product, which is shown here in an example area from Spain. This timeline shows the crop type product from 2017 to 2021. The crop type itself consists of 17 classes mapping quite variety of different crops. The greenish tones, especially in this southwestern part, are related to permanent crops, and those permanent crops consist of olive groves, fruit trees, nut trees, and grapes. And in this specific area, it's mainly olive groves. The upper part shows annual crops, which consists of wheat, other cereals, dry pulses, further classes. And here you can also see quite well that, for example, in the upper central part of these areas, there's quite a change within the crops that are grown within these 5 areas, and the permanent crops are stable throughout the 5 years in the bottom part. To summarize the available products within the new VLCC product line, so I mentioned it before, the cropland product services are new in the HRL portfolio. Here, the main status layer is the crop type product, which has the spatial resolution of 10 meter and also a minimum mapping unit of 0.25 hectare. Those crop products are accompanied by some additional expert products, for example, the cropping patterns, which have the same spatial resolution and also the same MMU of 0.25 hectare applied. And here there is some additional information given, for example, for the main crops. There are dates given when the crops emerge or are harvested, so you can calculate the crop duration on this specific crop parcels, or you can also get further information if there were secondary crops present in this area or not. And then another group of these expert layers that are provided are the confidence layer, which provide the confidences for each of these respective product types. And for the grassland product service, there are the well-established status layers for grassland in 10 meter and an aggregated version in 100 meter, as well as the grassland change layer with 20 meter resolution and a minimum mapping unit of 1 hectare, showing the grassland change in the time frame of 2018 to 2021. And the grassland product suite is now also extended with a herbaceous cover layer, which comes also in 10 meter spatial resolution. And this is mapping the temporary herbaceous cover throughout the 5 years. And also a new product in this product group are the grassland mowing events, basically providing further additional information on management practices on these grassland areas. Those grassland mowing events have also 10 meter spatial resolution and the same MMU as the previously mentioned cropland products. Besides that, there are also further expert products provided, which provide then the confidence values for each of the classification of the specific grassland products, and as well as the plowing indicator, which is also already an established product from previous HRL iterations. And then last but not least, the forest products. Here the main products are the dominant leaf type with 10-meter resolution and the tree cover density product in 10-meter and in an aggregated version of 100-meter. Those two main status layers are used as input to produce the forest type product, as well available in 10-meter and in 100-meter, which follows the FAO definition of forests. Then besides that, there's also the forest change product in 20-meter with an MMU of 1 hectare, showing the forest changes in the map timeframe from 2018 and 2021. And here as well are additional expert layers produced showing the confidences of the respective classifications, and as well as some further aggregated products providing information on leaf type density. All these products can support and aid different and various policies. The crop type, of course, can support and add additional information for the common agricultural policy. The forest products, of course, are suitable for the European Forest Monitoring Law, and also in the combination then of the forest and the grassland products can be used and provide additional information for nature restoration laws and the European biodiversity strategy for 2030. Before we go a little bit deeper into the methods and some class definitions, here's a short overview of the input and training data that were used to produce the different product groups. Of course, in the first, we use Earth observation data, and here rely basically only on the Sentinel data. Those are then combined with a large sample database, and the sample database consists of in situ data and ancillary data. So these are basically the Lucas data sets, ELPIS data, and when available national data sets and further data sets that go into the sample database are the CLC plus backbone, as well as further CLMS data, for example, from previous HRL iterations. All these data are harmonized and then compiled in the sample DB, and then via a cloud-based processing pipeline, there is a first initial product created, the base vegetation layer, which has only internal use, and this basically maps the maximum extent of the three product groups, so the maximum extent of the cropland, the grassland, and the forest products, as well as a background class. Once this internal first initial classification is done, then the Earth observation data, further Earth observation data, and more ancillary data are then used to derive the actual product. So the forest products rely mainly then on the Sentinel-2 data. For the grassland product, and especially the grassland mowing, then there's also the use of the HRL-VLCC data necessary, and the cropland products then also rely on the use of Sentinel-1. Before we go more into detail how the initial classification and then also the specific products are produced, a short overview of some definitions that are applied throughout the VLCC products. The vegetated land cover characteristics, so the VLCC align with the eagle nomenclature at the highest hierarchical level. So for those that are not familiar with the name eagle, eagle stands for the IONET action group, land monitoring in Europe. So this is basically a group of land monitoring experts which try to provide a nomenclature, a hierarchical nomenclature for land cover surfaces. And there are 3 blocks: the land cover component, the land use component, and then the additional characteristics components. And the VLCC products are, of course, then within these land cover component on the highest level, and the biotic and vegetation part of this EAGLE nomenclature. This leads us then to the question, what is considered vegetated and non-vegetated? There we set during the production a threshold where we say that for a pixel or certain area, the pixel has to be, or the area has to be covered by at least 30% throughout the year. And an exception here would be tree cover, which should mapped already starting with 1%. And how is this distinction made in practice? There we use NDVI values to define vegetated surfaces from non-vegetated areas. For Central Europe, or in general, there is a threshold used that vegetated areas are considered with NDVI values of 0.4 or above. And this threshold has to be met for at least 10 weeks throughout the year. So then that this specific pixel gets considered as vegetated. In dry areas like the Mediterranean areas or in Turkey, this threshold is lowered to 0.2 to adapt for the given local characteristics in these dry climates. This is also shown in this example below. Here you can see an example from Spain showing an NDVI profile from May 2017 until September 2020. So in the first 2 years from 2017 to 2018 until the beginning of 2019, there's barely any increase in NDVI values. So for those years, this area would be considered as non-vegetated. For 2019 and then the following years, there is a clear rise in the NDVI visible, and this area would then get labeled as vegetated, and with these specific NDVI characteristics would then be considered as cropland. So this would be the distinction between non-vegetated and vegetated within the VLCC products. And there is, besides that, also one further vegetated part that is not included in the VLCC products, and this land cover component would be the non-agricultural shrubs. So these are not mapped in any of the VLCC products. In the beginning of the input data, I already showed the presence of the base vegetation layer, or this initial classification that is then the input source for the production of the actual products. And within these 3 main groups, herbaceous and grassland, cropland and tree cover, there are by definition some overlaps allowed. For the overlap of cropland and tree cover, this would be the overlap of tree crops. This means basically olive trees or olive groves, fruit trees and nut trees, which would then be mapped in both products. For the overlap of tree cover and herbaceous, this would be areas where tree cover is only very sparse, so with TCD values of 1 to 10%. These areas could be mapped in both products, so in herbaceous and the tree cover products as well. And then the last allowed overlap then would be between the herbaceous group and the cropland. And here, for example, the fodder crops. And during the production process, it was decided to consider these then in the herbaceous group rather than as cropland. As mentioned before, all these VLCC products are harmonized. And this is done with an hierarchical approach for harmonization, which relies on this first initial classification. And this first initial classification shows the maximum extent for tree cover, grassland, and cropland, which is then used to derive the actual products for the forest group, the grassland product group, and the cropland group. On the right, you can see such an example of this initial delineation, which is called BVL, an internal product. So the first classes here are the main classes, herbaceous, coniferous, and broadleaf trees, and then the arable class, and then the allowed overlap classes with class values from 5, 6, and 7. This initial delineation fosters then the spatial and temporal consistency of the further analysis and the further production of the cropland, grassland, and forest layers. So there is like this first initial classification mapping the maximum extent of these layers, which then is used in the production of the actual individual products. This is basically the summary of this initial classification and how it's then used. So this base vegetation layer, this internal product consisting of these classes for herbaceous, cropland, tree cover, and the overlap classes is then given into the production pipeline for the grassland products, where the maximum extent and the probabilities that are produced during this first initial delineation are used to produce the herbaceous layer and the grassland layers and the change products. For the cropland products, the BVL serves only as the maximum extent. Here there are separate classification probabilities then calculated. And for the forest product, the BVL also serves as the maximum extent and providing probabilities, which are then further used for the production of the actual products. Now we are diving a little bit deeper into the base vegetation or initial classification, the leaf type and tree cover density classification, so the methods for the applied for the generation of the base vegetation layer and the forest products. So as mentioned before, there's the Sentinel-2 archive, which is used together with this huge training database, which consists of more than 1 million sample points spread across Europe. And those data are combined and then processed in a multi-year deep learning model. And this initial classification provides then classification probabilities for the main product classes. On a second processing route, basically, there is the TCD product created. This relies also on the Sentinel-2 archive, and as a sample database, the existing HRL 2018 is used to create a sample database. And here there's no not the same deep learning model used to model the tree cover density values, but a cut boost model is used then to gain the TCD values. The BVL and the initial results of the tree cover density modeling are then undergoing a multi-year consistency analysis. And during this process, there's also a change detection for the forest products done. As I said earlier, the initial classification provides probabilities, and those probabilities are then used to set certain thresholds for changes within the forest classes. So then these probabilities are used to assign gain or loss areas. Once this multi-year consistency analysis is done, the results of the BVL and the DLT and the TCD are intersected and harmonized, and then a final BVL layer is created, which is then shared with the colleagues for the grassland and cropland production. And then the DLT and TCD, so the main products for the forest product suite are already available, as well as the change layer, the tree cover presence change, and the dominant leaf type change layer. Once these basic main status layers are available, further derived products can be produced. This would be the basic overview for the methods of the base vegetation layer and this initial classification, and the main status layers for the forest products. And before we continue with the methods applied for the cropland crop type modeling, there is a new question on the Slido question available, and yeah, I will ask you to have a look there and yeah, have a short look at the questions there, and then we continue with the crop types.
Okay, so I will present here the methodology of the HRL cropland products. These products are designed to address current critical data gaps, enabling also now detailed agriculture monitoring at continental level with a spatial resolution of 10 meters. So also allowing doing analysis at field level. And also important is that these products are updated annually, so they facilitate also repeatable and harmonized assessments across Europe. On this slide, you find a high-level overview of the crop type classification architecture. This architecture employs a transformer-based feature extractor, which is followed by a multiple layer perceptron classification head. And this model utilizes a variety of Earth observation and auxiliary datasets. More specifically, it makes use of Sentinel-1 SAR-based data, Sentinel-2 optical data, and also additionally meteorological data containing daily mean temperatures and also altitude and slope information. And this diverse data set then allows us to better align inputs from different regions across Europe. The relevant features from these input data sets are then automatically extracted by an attention mechanism. And afterwards, these extracted features are embedded and concatenated before being passed to the classification model. And this classification model has been trained on multiple year ground truth crop type data that has been sampled across various regions in Europe. In the middle of the slide, you can find the established crop type classification nomenclature, so the classes we map out of the model. And this nomenclature has been defined after a thorough separability analysis, also ensuring that still the thematic detail and the classification accuracy has been reached within the project. Within this nomenclature, the most common cultivated crop types within Europe are captured, and also annual and perennial crops are mapped. For each crop class, the model generates a probability estimate, which is important information for understanding the reliability of the mapped outcome. And in order to operationalize this classification approach, this entire procedure has been integrated in OpenEO, which makes it more easy to scaling up this approach. Now let's discuss further on the post-processing steps that are applied after the raw model output has been produced. So first, we filter out non-cropland locations using the base vegetation layer, as already mentioned in the previous slides. And next, we translate then the raw outputs into a single classification prediction based on the class with the highest probability. Afterwards, we also perform some spatial cleaning and interannual consistency checks to ensure that the output is consistent, both looking on the temporal scale and also spatially coherent. For the locations where the maximum probability of the selected crop class is still below a certain threshold, we assign the label to an undecided class, and there we make a distinguishment between annual and perennial crops. The final products then include both a crop type classification map and also a confidence layer that represents the probability of the selected crop type class. Next slide, please. So now I will talk a little bit more on the second part of the cropland products, which address the agricultural practices that also are produced at 10-meter spatial resolution. And this product suite consists of several expert products that are designed to provide detailed insight into agricultural activities. As you see on the simplified processing workflow, the mapping process begins at the field level to ensure that we capture homogeneous patterns within the same field. And in order to achieve this, we need a field delineation algorithm that defines the boundaries of the field. Once we have this information about the boundaries, we combine this together with the crop type classification results, as we only focus on annual cropland. And based on that, we define which cropping pattern parcels we can use to create the different expert products. For these remaining parcels, we request an ingest time series from both Sentinel-1 and Sentinel-2 satellites into a crop harvest and emergence detection algorithm. These algorithms analyze the entire time series and identify all the occurrences of crop emergence and harvest events within the time period. And from these emergence and harvest outputs, we can derive a growing season. And then this growing season information serves as the foundation for the different cropping pattern products, which are categorized into 5 thematic domains, as you see here on the right-hand side of the slide. The first one are the main crops. These products define then basically the emergence, the harvest, and the duration of the main growing season. And each product is accompanied with a confidence layer to indicate the reliability of the output. Then the second one are the bare soil products. These products define the length of the bare soil period before and after the main growing season. And this duration is calculated based on the calendar boundaries and or the presence of a harvest event prior to or an emergence event following the main season. Again, a confidence layer is added here to indicate the uncertainty on the duration calculation. Then the third thematic domain are the secondary crops. These products focus then on the growing season of secondary crops that are cultivated before or after the main growing season. And this is typically happening during the off-season. Within this product, we provide information about the emergence, the duration, and the type of secondary season. The type of secondary season is now including 4 categories that are defined after some express rules based on the emergence period and the seasonal length of that season. Again, confidence information is provided regarding the emergence date and the duration of the secondary growing season. Then the fourth one are the fallow land locations. And here this product identifies cropland locations that are temporarily not cultivated. It provides information on which location this fallow land was present and also the duration of the fallow land periods between 2017 and 2021, with also confidence information on the duration available. Then the final group are the annual crop characteristics. One of these products provide information about the number of growing seasons within a calendar year, which is the maximum of 2. And then the other product details the crop rotation of the main crop type over a period of 3 years of the crop rotation. So that was the main methodology about the cropland products.
Then we would hand over to the colleagues from GeoWill. Tanya?
Yeah, so I will continue with the grassland methodology overview. For the grassland herbaceous grassland change in plowing indicator, this is the first row here. We use the BVL probabilities. The BVL is the layer used for this harmonization. Christian already presented a bit earlier. We use these outcomes of this BVL herbaceous class, the probabilities, together with the CLMS, HRL, VPP, PPI. So the plant phenology index, time series, and some auxiliary data as the CLC, traditional CLC, and also the existing grassland 2018 product. The first step is like, to retrieve these probability estimates from the BVL herbaceous class. Then we try to find a threshold in the reference year by maximizing the accuracy by comparing it to the CLMS products. The probabilities will then be tuned by dampened the probability of selected classes using this additional data to eliminate false positives, and also to harmonize probabilities between the yearly layers to reduce rapid changes. Then the threshold is applied to all years to determine these binary layers. Like the herbaceous product is same as the others, a 10-meter product, a yearly product starting 17 to 2021, but will be also for 2023. Is like the first layer, and the other products are mainly derived from this product. So the grassland, the herbaceous, is containing permanent and temporary grassland. As we learned, it also includes the fodder crops, whereas the grassland product has to be permanent grassland for at least 6 years in a row. So no blowing event has to be taken part in the meantime. The grassland layer is then derived from using the herbaceous and the blowing indicator, by just masking out the pixels or patches that were plowed in between. The blowing indicator is an annual product that indicates the temporal extent from 0 to 6 years since the last blowing activity on non-permanent grassland. And therefore we use also this VPP, PPI to determine real changes in this product. Then we have the grassland change product. There we we aggregate to 20 meters using a majority rule. Then we assign the specific grassland change classes, so non-grassland in both years, grassland gain, grassland loss, and grassland in both years. We use also this VPP PPI product for indicating these losses and gains, and then it will be sieved to this threshold of 1 hectare, and then the grassland change is derived. The grassland is of course not a yearly product, but a 3-yearly product. It's the 1821 grassland change product. All the products are accompanied by a confidence layer, the grassland and the grassland change. And in addition, we have a 1 meter aggregated product. For the grassland mowing, we use the full Sentinel-2 archive starting from 2017 to 2023. We also use the HRL-VPP, but here we use this start of season and end of season date to determine the vegetation season, since it's not the same for whole of Europe, especially the Mediterranean or Scandinavian regions. They are quite different. And we use, of course, the herbaceous layer as an input because the mowing is only detected in the herbaceous product extent. So there we do a time series analysis. More or less, the mowing events are determined by looking for disturbances, so unusual sharp drops in biophysical signals, mostly in the NDVI, compared to reference values. For this reference value, there was a model was developed that gives us here an indication on that. And together with that, we derive then the grassland mowing and the grassland date product. Same as above, we also have accompanying the product with the confidence layer, also on this yearly product. That's from my side.
All right, thank you, Tanja. And yeah, with all these different kinds of products and methods shortly explained, we want to show and highlight some of the products in different areas. So here in this first example, we can see the in-valley area in Austria, surrounded by the north and south by the alpine mountains. At first, there is the forest product overlaid, and then followed by the temporary grassland for 2021, and then finally the crop type product. And as you can see here, the forest products map the coniferous tree cover, especially on the hill or mountain slopes, and then some broadleaf covers then also present rather at the valley or the lower sections of this area. And what can also be seen here, then the agricultural activities are basically limited then to the areas within the valley. The second example, which is quite different then, is here from Belgium. Here as well, the forest products are overlain, and then the grassland product, and finally the crop type product. Here there's quite a different situation. The broadleaf tree cover are mainly spread across the whole area, but they are quite segmented in the northeastern part. We have also quite some areas with coniferous trees. The central part of this area contains also quite a lot of grassland areas, and then in the bottom part of this image, you see that there's quite a lot of different agricultural activities ongoing there. So the crop type delineating there the different parcels where different crops are grown. And then the final and last example for now would be a one in Spain. Here you see large parts covered also with broad-leafed trees, and only a small section in the eastern part then classified as coniferous trees. In the northern part of this area, there's then also grassland and herbaceous cover mapped. And as you can see here now, there's also quite the overlap of the allowed overlap of the crop type and the forest product. As you can see here in this step where the crop type is added, there is this yellowish green tone, which is applied for the olive trees, which are covering the major parts of these areas. But you can also see that then in some areas close to the river in the western and southwestern part, there are also other crops, annual crops grown. And this serves as quite a good example of these allowed overlap of the tree type product, which maps the broadleaf cover, and then the olive trees, which are then also mapped in the crop type product. Before we continue with the next part with how to assess the data, there is again a new question available on the new Slido question available. Please have a look at it and answer it, and then we would continue with how to assess the data. By Tanya again.
Yeah, so the question is how to access the data. For the moment, it's not published yet, but just to explain you already the possibilities how to access the data. So there are three primary methods for geospatial data access. So it's an API-based solution. It's using this harmonized data access, HDA, on Wikio. I guess everybody is familiar with Wikio in the meantime. Then it's the tilemap server, TMS, is integrated with MB tiles. And of course, I guess already you know the EEA CLMS portal. So flexibility for this, for downloading this raw geospatial data and easy visualization in web applications has the highest priority. So the API allows to retrieve specific EA tiles with corresponding metadata, of course, and also statistics and of this data. The TMS offers a seamless visual experience through these hosted MB tiles. They're pre-calculated and easily to be embedded into web applications. So you can visualize the data there, zoom in and out, and then you can copy like the WMS link and integrate this into your web applications. The CLMS portal offers visually guided data download based also on an AOI. I guess you know the portal, and you can draw an AOI, select the product, and then download this area of interest. Next. Yeah, so just a short summary. So the HDA platform on Wikio allows users to search for geospatial products based on an area of interest. The platform then returns relevant products based on EA 100 kilometer tiles intersecting with the defined AOI. Next. Yeah, here you can see a visual of this GUI, but it's not only this GUI, but it's also an API. You can also code-based assess the data here by applying the year and the product type. So you have this 5 years for the moment, so 17 to 2021. And then, for example, you use here in this grassland VLCC, grassland change or grassland change confidence layer. As in this example, you have this AOI, and then it shows, next slide, it shows all the products that are available for this time frame. So for the year we have selected 2021. The change product is in 20 meter, and it shows it's EA tile 43 and 25 in layer projection. And then you could use this card button and add it to your card and then download the data already, or use the API to also further download this on a script base. Each product will then include a zip file containing the TIFF, geospatial image, a metadata file for further reference and processing, and also, like I mentioned before, some statistics data. Next. Yeah, the tilemap server offers a method to access geospatial data visually. A preselected set of products is converted into MB tiles, which means it's already this tile is also applied to this and hosted on this server as a single layer. These layers are highly versatile and can be integrated into any web application for fast and efficient display. So using this as an WMS service, it's quite easy. Next one. And the last one I already explained. So the CLMS portal will then also offer a simplified data access. As you can see in this example, it's not the current one, the VLCC, but the tree cover density, for example, for 2018. It's also a visual GUI. You can visualize the data, also draw an AOI here, and then this registration on this, you can then download the data here. It's all the limitation. It's only a small area available for this download. Okay, I think that was on the data access.
All right. Before I continue with the internal verification process, there should be again a new question available on the Slido. So yeah, please continue answering the questions there. Yeah, to ensure the good quality of the different products, there are basically 3 steps taken during the VLCC production. The first step doing this quality assurance is basically during the production process of each of the partner, doing the production of each of these layers. And once the main status layers are available, they are checked by another party which is independent and was not involved during the production. And in these internal verifications, the main status layers for the forest product, the DLT and the TCD, are checked for the reference year 2018 and 2020 and 2021, as well as the forest change layer. For the grassland layer, the internal verification is done on the grassland status for 2018 and 2021, and as well for the grassland change layer. For the crop type, there are several checks done. For one, the crop type check with following the same approach as the checks for the other status layers, has an aggregation of the previously 17 classes of the crop type product. Those are aggregated to 6 classes, and then these 6 classes get checked during this verification process. And then there is a specific second approach used for the crop type verification, which has again aggregation of these 17 crop type classes into these into 11 classes, and then verification is done based on these 11 classes. In the center of this table, you see the accuracy targets for each of the products. So for the status layers, for the forest product layers, these are 90% for users and producers accuracy, as well as for the forest change. For the grassland status, it's 85% overall accuracy and 80% for the grassland change. For the crop types, there is a different metric used to doing this verification process. And there, in the first approach, the F-score of the classes of 85% should be met, and with the second approach, the F-score for these classes should reach 80%. Shortly, an introduction to these 2 approaches that I mentioned earlier. The first approach that is used for all the status layers and the change layers is based on a non-stratified systematic and random sampling based on the Lucas grid, and applied for the status layers and the change products. There, a double-blind approach followed by a plausibility analysis is done to retrieve the accuracy metrics. And then for the crop type level 2, so this second approach for the crop type uses for the verification of 2018 Lucas data and Lucas crops allocations data that were not used during the crop type training. And due to the absence of Lucas data for 2021, there is a different sampling method used for the verification of 2021. Here, LPIS locations that were not used for the training are used. And there is a similar sampling effort used so that the revised samples or checked samples are or have the same amount as the Lucas locations checked for 2018. And here the checks for these crop type level 2 focus mainly on the confusion between the different crop types, which is done in this second approach. The omission and commission errors and are already covered then with the analysis during approach 1. The results of this internal verification showed that the accuracy targets are largely reached for most of the products, but there are some known limitations. For one, there are potential overlaps, not only the allowed one that I mentioned earlier. So some HRL-VLCC products can have some overlaps to the class definitions. So the crop trees and the broadleaf classes can have some overlaps, especially in the transition areas. Then there are certain areas which are rather difficult to map properly, especially the Mediterranean area and northern Scandinavia, due to northern Scandinavia due to the increased cloud cover, and in the Mediterranean area due to rather dry surfaces, for example. And especially for the crop type, there are some problems with rare classes. So for example, would be here flax, soybean, and rice. So there are not much sample data available to train the model appropriately, and also for the validation and verification, it's quite difficult to have sufficient reference data available there. And the same is then also for the grassland mowing, where the accuracy might vary for different regions because of the lack of available in situ data. All the insights of the verification and the more detailed descriptions of the products and the methods used to produce these products will be published in the product user manual and the ATPD, the algorithm technical basis document. Those will be provided once the data gets published, and together with the actual raster data, there will also be Inspire compliant metadata delivered with each raster containing further information and statistics. And with that, I would hand over to Ludvig again.
Thank you very much, Christian. Yes, and along these lines, I also want to present a bit on what we call the external validation. We have a second phase of validation for these products, and in general, in the CLMS from now on, we have an independent external validation performed by different consortia led by EFTAS, who are setting up or have been setting up for the past half a year a validation framework and database and so on, and also defined validation strategy and validation areas. I will just go through a bit on what has been applied here for the VLCC and what will also be made available shortly. So validation areas, they have defined on the right here, that is highlighted as the first one. You see an example sketch. Also part of this independent validation is that they keep the validation areas kind of secret, so that it cannot be or so that the results are not possible to alter for the results. And these are selected on based on NUTS2 regions. We try to ensure biogeographical distribution so that it represents the different land cover types of Europe. It's also ensured that these validation areas include many different land cover types, not only for VLCC but also for the rest of the portfolio, so that it can be tested on in the similar way. And then also, of course, reference data availability is important for the selection of these validation areas. Then a sampling design where a frame is based on the Copernicus reference grid, and as you see in the second example here on the right, where certain grid cells are selected on a stratified random sampling, and then thirdly on the sampling point, right, which is populated with the validation data from the validation database. A sample located which is extended to 5 and 20 meters radius. Next slide, please. And just an example for the VLCC, we have selected certain data sets for certain testing or assessments. So here you see in green the reference years and each product that have been selected for this first validation campaign for the phase of 2017 to 2021. We're looking into the forest type, also the tree cover density and the grasslands. As you can see, for example, the grassland has been selected with all reference years because there we want to test the time series consistency, for example, for all years. I mean, time series consistencies are checked in other layers as well, looking at the crop types, for example, the 18 and 21 is compared and so on. But different methodologies for the different layers. And then in the next campaign, it will look a bit different. We will test certain aspects. Next slide, please. Then a bit on the outlook. So as we see now, we have the publication upcoming for this first phase of the VLCC, where we also, of course, have worked quite a lot on getting the model established, which now the output of 2017 to 2021 is planned for end of October for a publication. So it should be published for when we have the next webinar in this series, for when we will look into the thematic application of forests. Then we're already up and running. So now we are trying to catch up with this model. The model is established, and we are having a kind of a overall goal of producing these products on a N plus 12 months basis. That's the end goal. Let's say we will see when we reach that time latency. So 22 and 23 is being processed, and we are also setting up the publication expected in about a year. And then we're also setting up now the processing of reference year 2024, which we will see publishing probably at the start of 26. So that's where we're starting to close into our N plus 12 months. I know there was a question already in the Q&A. Of course, the Q&A is soon, but to mention here, the inclusion of the UK, this is something that in the beginning of this year, the UK rejoined Horizon and Copernicus, and there's still some aspects to be settled there contractually, and the budgets and so on. But what we foresee is for this phase 3 to also catch up the UK. So what we want to do in VLCC, not only to hook on UK when they rejoin, but we want to ensure that the full VLCC portfolio time series is processed for the UK. So there will most likely be a reprocessing or a processing of the 2017 onwards for UK, and will be released in this phase 3 when we reach the end of it. Next slide, please. All right, so a bit of a summary before we go into the Q&A. What we've looked into today is, of course, the VLCC portfolio with these 3 major vegetation products, classification and land cover products. It provides a seamless continuation of the HRL Forest and HRL Grassland, as we've has a time series on a 3-year frequency from 2012 for forest and 2050 for grassland, and of course now with a quite major update of annual production and additional layers. And then, of course, the novel product of crop types and cropping patterns, which is filling the gap in our vegetation monitoring. Change layers will remain on a 3-year cycle, and there's also some examples. For example, the forest type. The forest type, we haven't gone into it in depth today. We will in the next webinar, but the forest type is taking the tree cover density and the dominant leaf type, filtering it according to FAO definition of forests, and using other input data to determine to remove tree cover in agricultural context and urban context and so on. And due to different aspects, for now, that will also remain on a 3-year basis. As you saw also in the validation slide, we have 18 and 21 produced within VLCC. These layers provide high accuracy. We will also see this in our different internal validation and also in the external validation report, where we will present in detail how these products perform. And of course, we also try implement harmonization and interoperability assurance with VLCC, but also with the other CLMS products. And a growing demand in the is of course in the policy context. We get quite some requirements from potential policy applications of these products, and these can be with the addition of the crop products is of course the CAP, the Common Agricultural Policy. They're not yet in place, but is being in proposed state is the European Forest Monitoring Law. Of course, that's an interesting law. The proposal is mentioning the products of the VLCC. We of course have the LULUCF regulation, and there's many more that are interesting for these this production. Next slide, please. I think it is the Q&A, exactly. So some questions I have mainly is the UK, and I will go through. So you see on the Slido, you have nicely voted up the questions that you consider to be as a collective being the most interesting ones. I will give the word to the different experts in our panel here. Some questions I might answer be simple to answer, like the UK one, for example, by myself. And I also urge panelists, if I do that, and if you find something is missing, just turn on your mic and say it. We can have a bit of a discussion here. Okay. Sorry. First question, and this is the top voted one. So now I will go through in the rank. So don't vote too much, because then you will mess up my my flow here. The first one is a very relevant one. A lot of abbreviations. I think we will also take this to the next webinars. Indeed, we should not. We're very much into this product, and of course the abbreviations for us is very straightforward, but not for you. So we will ensure to take this as a lessons learned. There is, as Christian mentioned, there will be documentation for all of these products, and of course it will be very clear there with the abbreviations and the full names. So sorry for that a bit, but we hear it. It's a bit of a disease with all the abbreviations. Okay, second question. Could you please share a link to the peer review publication that summarizes all things being presented? Yes, all things presented today, I don't think, but in general on the methodologies and so on, we will, the ATBD, the Algorithm Theoretical Basis Document, not to use the abbreviation again, will be a kind of your go-to document for these things. And that will be properly referencing the findings that are done within the assessment initially in the ramp-up phase of this project, but also referencing already known knowledge that has been fed into the models and so on. I hope that answers your question. If there's anything else, of course, also the validation strategies and so on will be very clear. We will have validation strategy documents for the CLMS when it comes to the external validation, and of course also in these reports it will be very clear what we're presenting. Now we see something has changed here. Okay, is there a product user manual available? Soon it will be available with the products being published. So we're working on the final edits of this the manual. This will be available to you. Okay, next question. What is the prediction accuracy of the different crop types? And this question, I think it will be most suitable to give to Casper, if you have some insights here.
Yeah, I can give a general impression about the accuracy. Of course, it's also dependent on which crop type you're looking at. But in case of the annual crop types, the F1 score is mostly above 80%, sometimes about 90%. For the perennials, it can be somewhat lower, but also depend on which perennial you're looking at, but it should be above 70%, I think, most of the times. And it also depends on, of course, to which region you're looking at, but generally speaking, that are accuracies you should take into account.
Yeah, exactly. And accuracies, as Christian mentioned, we have in different aggregated levels. These also in the external validation, these are looked into, but we also present on a specific crop types, the found accuracies there when testing with the reference data. Now let's see, where was I? Yes, by Zacharias, were any ground truth data used for the harvest and emergence events, or were those estimated from Earth observation solely, I guess I would add there. Casper, I give that back to you again.
Yeah. For the harvest and emergence events, the data come from different platforms. One of the platforms is a Pito platform where farmers register information about emergence and harvest events that we could use. On the other hand, there was also a kind of public available app in which different users can collect phenological information through field observations. So we also use that in kind of information and pre-process all the data to allow it for training the model. So yeah, we use some in situ data to train it.
Okay, thank you very much. Hope that is clear. And then for the next one, interesting, but a lot of information to process today, indeed. Will the datasets and documentation be available by the time of the 3 follow-up thematic webinars? Yes, this is what we're aiming for now, to have it online at the end of October before our thematics webinar commence. So expect us to have a small session in the start there, announcing that the layers are now accessible. And they will be accessible on different platforms. And the first one will definitely be Wikio, and then also the CLMS portal. I know there's a question in here somewhere on the CDSE, and yes, that is also in the pipeline. And in general, my colleague Matteo is working with the I shouldn't say migration, but adding all the full portfolio to the CDSE, and this is being done in different stages and so on. So that we're kind of in a in-between stage here with our dissemination. But the CDSE will be one of the core dissemination platforms in the future for the CLMS as well. Okay. And then next one is some development done on wetlands and peatlands classification. I will leave this to, there's probably some insights here. This is not, from my insights here, this is not part of the VLCC, specifically mapping wetlands and peatlands. These are not in the nomenclature, let's say, but there are other products, and of course there's overlaps with I could imagine grasslands and so on. But maybe Tanya, do you have some insights here?
No, sorry, no. Also not in the WSI. It's also not planned the wetland or peatland mapping yet.
No.
Other than that, I don't know. Sorry.
Exact. Yeah.
In VLCC, they would typically go as grassland or herbaceous, yeah. And if there's too much water, they would then, like, the water surfaces, they are out. They are not in the maps.
Exactly, and then most likely they're captured in what Tanya explained as a WSI. That's a different product in our portfolio called the water, snow and ice, which is, if some more historical users might remember, that the HRLs also included the water and wetness class and layers, and these have now been transferred to the water, snow and ice production flow. So we have the VLCC.
Only the water, not the.
Yeah, exactly, only the water. So the VLCC is the vegetated. We have the non-vegetated in the NVLCC. That's where the imperviousness products and so on are found. And then the water is transferred to the WSI. But no specific classification of wetlands and peatlands in the full portfolio. Okay. So Miguel, we have a question from you. Could you provide more details about the difficulties in Mediterranean area? Which accuracies have you reached in these areas? That's a very good question. I would start giving this to Andre maybe, and then people can.
Yeah, I mean, on the tree cover mapping, what we've seen is that we're generally above the 90%. There's only a bit of emission, like maybe 11% of emission on the broad-leafed tree cover, and most of the issues come from the Mediterranean. So where we have very sparse tree cover, some of the olive groves, for example. We did a lot. We even did some reprocessing to reduce these emissions, but it's hard to get fully rid of them. So that would be maybe one issue to be aware of in the Mediterranean. And then there are, let's say, some heterogeneous landscapes in the Mediterranean where it's a mix of trees and shrubs and some crops intermingled with dehesas are typically difficult, where you have sparse tree cover and crops and a mix of crops and grassland in between. That's a bit hard, let's say. Yeah, so in these areas there it might be a bit below average.
Yeah. Anyone else want to add to Anders' insights there? Okay, we only have a few minutes left, but I think we can cover. We have a lot of questions, so thank you all for that. And so I will continue. Maybe we have some quick questions. I will get back to the in situ data on grassland and give that to Tanya. But first, there's some questions on the expert layers and the accessibility of these. These will also be published. All of the layers you've seen today will be published, so all the confidences and so on.
But you won't find. There's one question: if all the probabilities are in there, you won't unfortunately find the probabilities for all the classes. It's typically something like the probability of the winning class or the margin of the winning class to the second highest class. The details can be found in the ATBDs and in the user manuals, but I think in most cases you don't have the probabilities for all the classes.
Yeah, that's true. Then we have some on in situ data, reference data used for the crop types. There's a question, and there, Casper, you can correct me if I'm wrong, but we are using Lucas data and also from the LPIS, the GSAA data, the geospatial aid applications from the land parcel identification system of the EAX system.
Yeah, that's correct. Yeah.
Those are the two, right? And then we also have a question on similar question on what data is used for grassland mowing events, Tanya.
For the grassland mowing events, it's data we created ourselves. We checked a lot of webcams, mainly in where they were available, mainly Germany, Austria, and all these tourist areas. We tried to find it on a global level as well. The phenology cameras, and we created these data ourselves, also for validation. But of course, many areas were not covered, so ground truth data is not available, unfortunately. Yeah.
Exactly. Availability of these type of data is quite sparse, and it's something specifically on the mowing events we're working on expanding the data sets. Not only us, but many different entities. We, for example,
sorry.
No, Tanya,
for
please.
Austria, we have a cooperation with the AMA, the Austrian Agricultural Market Austria. And there we have a lot of ground truth data available from the farmers directly. It's something like the ELPIS data for Austria, really detailed. That one we used for development based in Austria, but it's also difficult to transfer this to different regions because Austria, of course, a different climate, different area than Mediterranean area, for example. But yeah, for development, we had a good training data set in Austria.
Yeah. All right. Time is unfortunately already 3:30. That's the end of the webinar. So sorry for not answering all your questions. But let's move on to the next slide. and end the webinar. So just a repetition here. Thank you for coming today. Hope we could provide you some insights into the products that are upcoming. And then please join us for the next webinars as well. It will be very interesting with colleagues from different organizations describing on how they use data sets, how they're planning to incorporate these data sets in their workflows and for policy, but also for other applications. Of course, to follow up on the dissemination of these data sets to make them all available to you, because that's what we're trying to do as soon as possible currently. And there was some comments as well. I know I can just mention it. There's been some delays on the initial communicated publication dates, and unfortunately we have had some contractual and production delays that has pushed this deadline a bit, but we're currently working full speed on getting these products as soon as possible to you. So please be patient, but not for too much longer. All right, thank you all for today. Thank you all panelists, and thanks to colleagues at NovaSpace for facilitating the webinar and the technology, etc. I think we have a thank you slide, so I'll leave it at that. Thank you very much.
Thanks, everyone.
Thank you.
Thank you.